Let's look at an example from 17A, looking at differentiation by first principles. If you haven't yet watched the notes video or read your summary guides and textbook, please do that before looking at this one. So we need to find the derivative of f of x equal to 3x squared plus 4x plus 3. So our formula for the derivative by first principles, we'd say the derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So let's sub in x plus h. We'd have 3x plus h squared plus 4x plus h plus 3. And then we're subtracting our original function, 3x squared plus 4x plus 3, all divided by h. Okay, main thing, remember we keep the limit notation in there. So derivative is equal to limit of h approaches 0 of all this jazz, so let's tidy that up. So let's expand out the brackets first. I get 3 outside of x plus h all squared would be 3x squared plus 6xh plus 3h squared, and then 4x plus h would be 4x plus 4h plus 3, and then I'm subtracting 3x squared, subtract 4x, subtract 3, all divided by h. So let's tidy this up. 3x squared minus 3x squared, I've got 4x minus 4x, 3 minus 3, and that would leave me with, we've got 6xh plus 3h squared plus 4h, all divided by h. And as h approaches 0, we can sub in h, or we can't sub in h is 0 yet because we've still got the denominator, so let's cancel off a h from each of these terms. And I'd end up with 6x plus 3h plus 4. And as the limit as h approaches 0, that means I can sub in h equals 0 now because there's no h's in my denominator. So I end up with the derivative would therefore equal 6x plus 4. And that gives me a formula for a gradient at any point of that original function. So 6x plus 4 from our original function, which would be 3x squared plus 4x plus 3. Okay, it does look like a lot of working out, but you should, if you've done it correctly, find that all your h's are cancelling off and you have no longer have a h in the denominator. If you don't have a term in the numerator with a h in it, something's gone wrong along the way. Okay, so the h should cancel off if you've done it properly. All right, all the best for the rest of 17A.